Hello students. Today we're going to be learning about 30, 60, 90 special right triangles. Let's begin with this warm-up. So find the missing side of the right triangle using the Pythagorean theorem. Looking in example 1, we see that 5 is a hypotenuse, so we can write this as 4 squared plus x squared equals 5 squared. Simplifying, you can see 4 squared is 16. And x squared equals 25. As we go through it, you can check the work at the very end. You should get your answer is x equals 3. Looking at number 2, this time the hypotenuse is x, so it's really important to make sure you write the correct first step. So 2 squared plus 6 squared equals x squared, since x is on the hypotenuse. Simplifying all the way down, and we end up getting that x equals the square root of 40. When you simplify the square root of 40 using the factor tree, you get x equals 2 square root 10. Okay, so at the end of this lesson, you should be able to find the missing sides of a 30, 60, 90 degree special right triangle when given the hypotenuse or the short leg. So first, let's go ahead and make sure we're writing down this triangle here. This is called a special triangle because it's 30 degrees, 60 degrees, and then the right angle would be 90 degrees. So there's a couple things we need to understand. So the side that's opposite the 30 degrees is called the short leg because it's the shortest leg of the triangle. Opposite the 60 degrees is the long leg. So you can always find where the short leg and long leg are by looking directly opposite of them. The hypotenuse is always opposite of the right angle. Okay, so let's see if we can try some examples here. So in example 1, it says, given this triangle, find the missing sides. So we're given it's a special triangle because it has 90 degrees here, 30 here, which means the leftover would have to be 60 degrees here. So as we're thinking of a strategy to solve this problem, you might be thinking, well, why don't I just use the Pythagorean theorem, since that's what we've done all along? And we could try the Pythagorean theorem since it is a right triangle, but look what happens. So we can write a squared plus b squared equals 2 squared. And as we try to simplify, we're stuck. We have two variables, and there's no way that we can solve this. So the big difference between these problems is that there are two missing sides, A and B, we need to find numbers for. Look in the warm-up, as we go back, there was only one missing side, so it was possible to use the Pythagorean theorem. So since we know that the Pythagorean theorem does not work, we need to come up with another strategy to solve for the missing two sides of this triangle. The strategy that we're going to use is by thinking back a couple chapters when we covered transformations. So what would happen if we took this triangle here and reflected it to the left? And what I mean by that is over the long leg here. So looking at this side here, the long leg, I want to reflect the triangle over that leg. So what I mean is that I'm going to take this triangle and flip it like this so that it flips onto this side. So I just made two congruent triangles because I took the exact same triangle and just flipped it. So the 90 degrees flips over here. The 60 degrees from this corner reflects onto this side. And the 30 degrees up in this corner reflects right up here because all I did was take a mirror image right over this line. So now that we look at it, the big triangle, notice that we've created an equilateral triangle because this is 60, 60, and 60 degrees at the top of that triangle. This is really nice that we have an equilateral triangle because we know equilateral triangles have all sides that are the same. So if we're given that this side here is 2, that means this side here has to be 2. And let me make sure you guys can see it. So this hypotenuse of that small triangle here is 2, which means this side over here must be 2 because the whole triangle is equilateral. And that also means that down here is also 2. So from here, all the way from here to here is also 2. If we created 2 congruent triangles, A must be 1 then. So let me just put a 1 here. Great. Okay, so now using the idea of reflection, we created an equilateral triangle. So we filled in 2, 2, and 2 on all 3 sides. And we were able to find this side length here as 1 because it's just half of the long side. Now let me draw this and pull it apart so you guys can see it. So we have the 90, we have 30, and 60. Back to the original picture. So we were given 2 here, and we just figured out that A is 1. So now we need to figure out what B is. Okay, well back to the warm-up. So now we're only missing one side of it. So now we can use the Pythagorean theorem. So now this is going to work. Let's go ahead and plug it in. So we get 1 squared plus B squared equals 2 squared. 1 squared is 1, plus B squared equals 2 squared is 4. We can subtract 1 on both sides, so we get B squared equals 3. Now take the square root of both sides to get rid of that squared part, and we get B equals the square root of 3. Great, so our final answer would be that A equals 1, and B equals the square root of 3, since we solved that part using the Pythagorean theorem. Okay, let's do a couple more examples. So look at example 2. So we're given the hypotenuse again as 8. So we first need to create one big equilateral triangle by reflecting. So I'm going to find where my long side is. So my long side is where the X is. That means I need to reflect the triangle over just like this. Okay. So that means my 90-degree flips here, my 60 flips into this corner, and the 30 flips right up here. Make sure that you created an equilateral triangle, so there's 60, 60, and 60 in each corner of the triangle. And now I've created one big equilateral triangle. So this side is 8, this side is 8, and this whole side must be 8 here. That means that y has to equal 4, because 4 would be half of 8. Okay, let's redraw this. So we have just this top part is how the problem started. So we've got 8 up here. We figured out that the short side is 4. Now we're trying to find x, the long leg. Okay, just like we did before, we're going to use the Pythagorean theorem. X squared plus 4 squared equals 8 squared. So that's x squared plus 16 equals 64. We can subtract 16 on both sides. So let's pull up the calculator. We have 64 minus 16. We get 48. And when we take the square root of 48, we need to break that down, because when we write the square root of 48, that's not quite simplified yet. So let's break that down. 48 is 4 times 12. 12 is 4 times 3. I'm going to circle the ends of that tree, so we get x equals 4 square root 3. So our final answer, you can see, is 4 on the short side, 8 as a hypotenuse, and 4 square root 3 as the long side. Keep in mind all the work we're doing here. Try to find some kind of pattern that will be helpful for us as we move on. Okay, let's look at example 3. So in example 3, we have the special triangle. We're going to reflect it over the long leg. So let's reflect it this way, because the long leg is right here in the middle. So the 90 flips over, the 60 reflects here, and the 30 reflects up here. And now I know I created an equilateral triangle. So as we look at this, if this part is 5, That means that this little part over here must be 5 too, because when we reflected, we made congruent triangles. So that means that this entire side now is 10. So this side must be 10, and this side must be 10. So notice a pattern that we're starting to see is that this short leg happens to be half as much as the hypotenuse, 5 and 10. Just like we saw in number 2 here, where the short leg was 4 and the hypotenuse was 8. Let's finish this one up. So let me redraw it so that we can see it one more time. So we have 5 here and 10 here, with the 30 degrees in the top and 60 in the bottom. And we still need to find x. So now that only one side is missing, we can use the Pythagorean theorem. So we have x squared plus 5 squared equals 10 squared. So x squared plus 25 equals 100. Subtract 25 on both sides, so we get x squared equals 75. And now we need to take the square root of both sides, so we get x equals the square root of 75. And we're not done yet. We need to simplify 75, so break that down with the factor tree. That's 3 times 25, and 25 is 5 times 5. So it looks like our answer will be 5 square root 3. So x is 5 square root 3. Let's go ahead and write this down as a note since we did notice one pattern here. So the hypotenuse is double or 2 times the short leg. This is the same as saying the short leg is half the hypotenuse. Okay, you guys try these 3 problems using the idea of reflecting, and then I'll see you in class tomorrow.